And then we get into section 3. Section 3 is all about emergency procedures. So what happens if your engine fails? If it fails during your takeoff run, guess what? You're going to land. If it fails after you lift off, then lower your nose, enter a glide, etc. So I would highly recommend, if you're even thinking about flying a particular gyro, just go ahead, go online and see if you can find a copy of its flight manual and just kind of read through it and get a little bit more familiar with that machine and how it works. One thing I did want to point out is if you are flying a Cavalon and you did have an engine failure while you're in flight and you wanted to try a restart, there's a note here that's telling you that you have to turn the key all the way to off and then back to start, because there's a safety interlock in there. So you can't go from on to start more than once. And that's a safety feature, so you don't bump the thing and it engages your starter by accident while you're flying. So keep that in mind. Again, I'm not trying to teach you how to fly a Cavalon here. I'm just talking to you about gyroplanes in general. And they talk about, hey, what if you had to land in some trees? What if your power is getting reduced? You know, look for a place to land. And some other emergencies as well. What do we do if we land off the field? If we have flight control malfunctions? How do we deal with those different malfunctions? What if we have a lot of vibrations? In general, when you have a rotorcraft, the frequency of the vibration kind of tells you where it's coming from. If you have a high frequency vibration, that is, in the case of a gyro, probably coming from your engine. If you have a low frequency vibration, that's coming from your rotor. You know, it depends on things like the rotor balance, and you know, there's a whole bunch of videos out there you can watch on things like reducing stick shake, and you know, where's it coming from? Is it coming from your prop? Is it coming from your rotor? And you can tell those things as well based on the frequency of the vibrations. What do you do if some other stuff fails? What about abnormal indications? What should I do with that? There is a note saying that, hey, this uses a CAN bus, which is a very common electrical connection used in cars a lot. And they're just telling you, hey, you know, these things might go full scale when you turn on the machine. That's normal. If a door opens in flight, it's not a big deal. The air will actually kind of keep it closed and just keep on flying. It's not an emergency. I saw a video recently of some idiot that had an electrical failure in his plane, and he thought that was an emergency when it wasn't, and he literally came in, landed, and crashed into another airplane on the runway because he was so intent on immediately getting to the ground. They talk about the different warning lights. What do they mean? They have magnetos. They call them lanes. They have lane A and lane B. And they tell you what do those lights mean if they come on. If they come on and they're flashing or they're constantly on, you know, what does that mean? What should I do? And you'll notice that some of them say land. What do you have if you have loss of visibility, rotor icing? What if you have a flat tire? What if your constant speed propeller failed, etc.? So those are the emergency procedures. Then we get into our normal procedures. Normal procedures, we start with things like what are our normal speeds. So we normally climb at 60 knots. Best rate of climb is 50. Our best range is 60. And our approach is usually at least 50. Then they have a bunch of pre-flight tasks. So they will actually walk you around the aircraft. And they have different stations. I would highly recommend, if you own an aircraft like this, take these pages, print them out, maybe mark them up for your particular aircraft and kind of go with that. If you're going for a flight test or a proficiency check, you are supposed to be using checklists. So definitely it would be good to have these checklists available. And then we have our operating checklist. Before you start the engine, are your pedals adjusted? Did everyone belt up? And are your flight controls free? Are your doors closed if they're on? And how do we start the engine? What's the procedure for that? What's our taxi and run up supposed to be? What's our takeoff like? I'll walk you through the pre-rotation and what that's going to be. Minimum of 200, maximum is 320. Then you'll take off. We've talked about how that works before. We'll get more into detail on that in future videos as well. What's your takeoff run going to look like? Obviously, you're not going to be looking at this checklist as you're going down the runway. What does a normal climb look like? Cruise, descent, approach, and your landing. If you have to do a go around, what does that look like? After landing, what are you going to do? How do you shut down the engine? Park it? What if you have a short field? How is that different? What if you're going very slow and you're sinking quickly? What if you have the doors removed? Well, it's pretty much going to fly the same. Just make sure you don't have anything that's going to fly out the door. Dropping parachutists, this is actually a thing, not in the US so much, but in other places. Noise abatement. And then we get into section 5, which is performance. So if you look at the performance section, it's going to start with things like, how do I convert and correct my airspeeds? And then here's our height velocity diagram. So again, when I'm higher, I can be slower because I have the opportunity to change my potential energy into kinetic energy. And that's going to get me to a higher speed so I can flare. So at 100 feet, if I look at the knot scale, I should be going at least 40. And if I look at 200 feet, I should be going at least, it looks like, we'll call it 37. And if I look at 300 feet, I should be going at least 24. Right? Now, this is too hard to remember, so I usually tell people I'm going to go with 30, 40, 50. Gives me a little buffer. So at 300 feet, if I'm below 300 feet, below 500 really, I should start thinking about my speed. And if I'm 300 feet in the air, I'm going to be going at least 30 knots. You know, if I'm trying to descend down onto a spot, I'm going to get a little bit short of it, and I'm going to slow this thing down to 30 knots. Below 30 knots, it's kind of hard to control because there's not a lot of airflow anymore. 30, 40, and then 50 knots. And that's going to help me come in and have a decent landing. They have the different speed limits. You know, what's your minimum speed? They say about 20 knots. Speed for the best angle of climb, 50 knots. Best rate of climb, 60 knots. Best range, 60 knots. Long range speed, it's kind of a compromise, 65 knots. Approach speed, 50. And minimum controllable with the power off is 15 knots. That means below 15 knots, you got like no airflow and you just can't control the machine anymore. But if you have power on, you can go to 0. Now, be warned though, there's a nice warning here that if that's the case, then you're going to have the nose way up in the air in order to make that work. They talk about takeoff and landing data. What's my takeoff roll going to be? What's my takeoff distance over an obstacle, 15-meter obstacle, which is essentially a 50-foot obstacle. And it's 90 to 100 meters. And then the whole takeoff distance is either 300 or 260, depending on my prop. And then I have my landing roll, 0 to 20 meters, landing distance, 150 meters. You might say, well, that's great, but that didn't really tell me much. And there's this chart that says, what's the performance hit for different weather conditions when it comes to my takeoff distance and climb rate. And they have an example on the next page. So I could say, all right, it is 28 degrees, and my pressure altitude is a little bit under 4,000 feet. So now my increase in takeoff distance is, we're going to call that 90%. So it's 190 meters now. And my decrease in climb rate is going to be about, call that 52%. So my climb rate's going to go down. And then they have sink rate and glide ratio for different airspeeds. If you have your engine at idle, and they have feet per minute and meters per second. And you can see your different rates at different speeds. So as you go faster, the sink rate's really going to go up, but it's fairly flat down here. It goes up a little bit as you go slower, but not as much as you might think. Then they talk about the fuel flow at different speeds.